All right. So this
On the clock.
Speckle session will be on next-gen web apps for AEC. The goal is to look at doing more than just sending data between proprietary softwares and instead to learn how to build the next generation of AEC applications with Speckle's developer tools. And the presentation is geared towards everyone from aspiring programmers to hardcore devs, and we'll showcase a few web apps that span that whole range of no code, low code to advanced Vue.js applications. So yeah, Alan, do you want to start off with an introduction?
Yeah, well, hi everyone. My name is Alan Rynne, and I'm a software engineer at Speckle. A little bit of background. I studied building engineering in Spain, and I have a master's in parametric design in architecture. And I've worked at several lesser-known companies before joining Speckle. I'm also a teacher at EAC, Barcelona University, and UPC, another Barcelona University, into masters geared towards computational design and visual programming in general. That's
Cool.
about me.
And I'm Claire, also a software engineer at Speckle. I have a master's in architecture and since graduating, worked for a few years at Gary Technologies in LA, doing a little bit of computation and a lot of bit of BIM automation on that team. And at Speckle, I've been mostly working in C#/.NET with our connectors, developing both the current ones and some new connectors as well. So let's get started. As a recap for anyone that might have missed the intro to this conference, the big question that we've been asking for a while is, what is Speckle? And we kind of think of it as a platform that offers three main features. The first is collaboration, sending and receiving your data from multiple applications and getting notifications of any updates or changes in real time. The second is versioning, so being able to keep track of all of your model changes, not on a file by file basis, but on an object level basis for each piece of individual geometry. And the third is automation, which we'll be looking at more in depth, but because of Speckle's comprehensive set of developer tools, you can really highly customize and even the most complex workflows and automate those. And these three features are enabled through the three pieces of Speckle. First is Speckle Web. We have a server, public server, and also web front end that is what you can use to view your data. We have some project coordination and management features being developed as well. The second are our app connectors. You might have seen a lot of notifications of new connectors coming in recently, but we have our core connectors are Rhino, Grasshopper, Revit, AutoCAD. We have some ArchViz connectors now, Unity, Unreal, and Blender, and we have a bunch of others on their way, structural connectors, and some civil applications coming in as well. And then finally, we have a developer platform where we have a C# Python SDKs, we have GraphQL APIs, and lots of documentations and guides for getting started. The second question is, why should you develop with Speckle? I think primarily the way we think about internally is falls in two bins. The first one is you get a bit of a platform network effect. So because all of your data is sent and received through our platform, translated into Speckle objects and then translated back, this means that the more data sources we integrate, the more connectors we develop, then the more data you have access to and the more powerful your data-driven applications will be. And the second, of course, the open source aspect of it. Almost every single part of Speckle is open source, and that allows you to take a peek into how we build everything, whether it's to improve your own development skills yourself or to hack a version of what we've already built. So we're going to spend a little bit of time talking about what the core developer, Speckle developer experience is before getting into our app demos. To summarize, the features that we offer are, as mentioned, our C# and Python SDKs. We have GraphQL and REST APIs. And then on top of that, we have a bunch of extra goodies on the side. The desktop UI that you see being used in some of our connectors like Rhino and Revit is available as a separate package. We have an awesome web viewer that Alan worked on. We have features like webhooks that for our Speckle streams and more. And then all of these are available, all of our libraries and kits are available via NuGet, NPM, pip, and etc. So part of or the Speckle application development process conceptually can fall into three separate pieces. The first piece is really defining what your data is. Everything that is sent through our Speckle platform is at its core a base object. These base objects can be customized and designed with whatever additional properties you'd like. We do offer an objects kit, which is our generic kit of geometry and a few preliminary BIM objects that you can add to your projects if you want to use that, or you can design your own custom base objects to send to Speckle. The next leg is in managing your data. So all of your base objects, your Speckle objects, are sent in streams, and each stream will keep track of when you send objects, what objects you send, who sent it, any comments that you wanted to add to the objects that you send, and other data for you to query as well. So part of what we offer with our API is the ability to create new streams, to manage your existing streams, or to query your stream activity. And the last leg is retrieving your data from the Speckle server after you've defined it and sent it. And so being able to query specific objects from specific streams or even specific fields of those objects for whatever your application may need is what allows you to then build some analytics and computation on top of those custom objects. All right, so we can get into some demos. I think the way we've structured our demos is we're going to start from the more hardcore applications and then slowly work our way down to some really simple no-code applications that you can use with Speckle as well. And Alan will get started with Revit Dash.
Let me see if I can share my screen. I think I have to override yours. There you go. There you have it. So first application I'm gonna demo for you is Revit Dash, which is kind of like a side application that we've developed at Speckle to extract information out of your Revit models. It's basically a Vue.js web application with no backend. So it doesn't have a server. You can basically build it and run it in GitHub Pages or any free place like Netlify or Heroku. at nearly zero cost, depending on your traffic. And it's basically, let me see if I can actually get to the demo itself. The way it actually works is you get to this website that it's at dashboards.speckle.xyz. It is actually public and everybody can use it. So we welcome your feedback on all of these apps, on what works and what doesn't, especially. And so basically, the logic behind it is that the application has the capability to log in with your Speckle user. So you're supposed to already have a Speckle account in our speckle.xyz server that you can all freely use. And once you have that, you need to kind of into the system, and it will ask you to, as any other normal application, ask you to allow for certain permissions that the application is gonna ask for. This is something that you can configure per application, so you can kind of like specify how much access or how little access each application has to your users' data and the data on those streams. And apart from that very red warning, what you will see is just a quick list of your latest streams that you've used, and a search bar that allows you to search directly on using our API directly on the Speckle server your available streams. So I could just write grasshopper, and it will tell me anything that has like grass on it, or do several searches to identify the stream that I'm actually want the report from. So since this is a Revit dashboard, we actually need some information coming directly from Revit. If you send from any other software that we support, this will not work. It's very Revit specific. But let's go ahead and just create a new empty stream in our server. Let me connect. Revit dash demo. I will make it public, and I could also add Claire as my. Oh, there's two Claires. Okay, well, I'll add both. There you go. And this will basically create an empty stream in my server, a place where I can actually push some data from one of the connectors that we have. And then I'm going to switch to Revit, which is the connector of choice. And here I have the Revit connector pop-up window, which you can access through the add-ins Speckle 2 Revit connector. We also have a new UI that you can test if you're willing to. It will be the official one shortly. So let's go ahead and just add this new Revit dash demo stream to our Revit connector. And as you see, once I hit the add button, it already shows me the latest stream that I created is that one. So I can just add it to my stream. And the requirement for this app is that you need to send absolutely everything in the model, including all of the project information, every single object, or else it will not work. So you can switch your card from a sender to a receiver and vice versa, hitting that double arrow button there. And then our button of selection objects, you can select a specific filter. And in this case, we're going to use the all filter, which is quite simple to set up. You just tell Speckle that you want everything, set the filter, and press send. It will ask you for a message. So hello, connect. And this may take just a second. And while it does that, basically what is going to happen is all of the data is going to be converted to our object model, which is also open sourced. And as soon as it actually sends, our front end actually realizes that new information has been received, and we can actually view it directly on our server or a web app, let's call it. So once we actually have this, we can actually go back to our Speckle Revit dashboard. And since we actually know that this new push a new stream that we've created contains a commit that has all of the data of a Revit model, this should actually work. We just need to search for Revit-demo. And here we have our connect Revit-demo stream. Now it's going to take a minute because what just happened right now is that we are processing all of the data live in your browser. So there's no actually data storage involved here. We're just like receiving the raw data and making a live analysis on that data on the fly. We're not actually caching or doing any smart strategies on this. And it will basically allow you to use our viewer packets inside the website to inspect the model that you're actually seeing and see if it's properly correct. We didn't enable selection capabilities in here, but to see like the metadata of each object, but we will if there's enough popular demand for this app to be improved. Then we also computed some very basic stats for the model, basically selecting every object by its category in Revit and grouping them by level and category, and extracting all of the families and types that a specific Revit element or Revit model contains. The way this is done, just for everyone to know as reference, we have a couple of NPM packages. I will remind myself. One is at Speckle/object loader. There you go. Which is the one that is actually pulling the data from Speckle to be able to analyze the Revit data in the browser. And the other one is at Speckle/viewer. Wrong URL. View. I was missing an E there. Viewer, which is the 3GS-based viewer that you can freely use in any of your apps. You just do npm install, and I think we have a demo on our website. There's no demo on the README right now, but there should be one. Oh, yeah, there's a link to the Speckle docs, which should have the demo to get you guys started. So that's basically it for the Revit connector. It's a pretty simple, straightforward implementation. Most of the complicated parts are actually the graph linking between the different data sets. So you can do filtering in one graph and have it on another. But the actual implementation of Speckle-related implementation is very limited to basically using the viewer to load all geometry into a 3GS scene, and using the object loader package to fetch all of the data from the Speckle server and analyze it using a couple of functions in our Vue.js app. And that's pretty much it. If you have any questions, we'll be happy to go over them in the end after we have the demo, just to ensure that we actually have time. For the next app that we've made, this one was made during a hackathon in our retreat in September. We basically whipped it up in less than a day, and you will see that it bears a heavy resemblance to the, let me see if I can actually walk through the, okay. Oh, yes, I skipped a small step. Did I? Oh, this slide is not correct. So next. So the next app that we're gonna show you is it's a very, very raw carbon report application that is basically very similar to the previous app that we've shown you. It's a Vue.js front-end application, but we also generated a backend to the application. So we would be able to commit data back to the Speckle server and save the carbon report information alongside the rest of the data of your model. So let me see if I can actually pull this one off also live. We also have a video if things go wrong. We will share you the links of everything, or maybe Claire is already doing so. so you can actually access the apps and test them out. And this one is in a very weird URL from Netlify that is auto-generated, so sorry for that. It's basically the same deal. You need to authorize the app to access the Speckle data. In this case, we're actually asking for more access because we needed information to not only read your streams, but also write to your streams to add some extra data into them. So once I've logged in, it's basically the same deal. But in this case, since we have a backend that is going to do the extra work for us, we need to do some previous setup on the stream itself for us to kind of like establish the connection between a specific stream that you want to generate carbon reports from and the actual server that does the work for us. So let's do the same deal as we did before. I'm going to just pop open a brand new stream, connect on report demo. Public, Claire, so she can share it. No, I don't have Claire right now. Oh, demonstrate to go crazy. Okay, so the way that this is going to work is the application, we're going to search in our application for a specific stream. In this case, the one that I just created, connect carbon report demo. And what is going to happen is that the application is going to check if there's a specific webhook already set up in our stream. Every stream has the capability for you to set up webhooks that communicate with other services when something happens. No, so in this case, what we're looking for right now, we have no webhook set up. So what we are looking for, I'm just going to close this because I keep confusing my tabs. Is once we set up this button, what our service is going to do is it's going to create this webhook for us with one event, the commit create event. So every time a commit is created in the Speckle stream, our service will get notified of that change, and we can act accordingly. So let's just hit that. And that's telling us that the reports will be generated next time the data is sent to the stream. So we can actually, if I actually reload this, we will see that a new webhook has been generated, and it has a specific URL from where our server is living, and a commit create event. You could actually activate more events in a single webhook and deal with that in your own applications. Let me just not delete that webhook now. Nice. So now that we've actually have this set up, the only thing that we remain to do is actually send some data to the Speckle server, and then the Speckle server will notify our Python server, and our Python server will pull all of the Revit data that we're sending, do some carbon report calculations on the different elements that the building contains, and save that data back into a new branch that is going to create in the stream called, if I remember correctly, carbon reports, or carbon reports, very aptly named. So I'm just going to delete that stream from my model. I'm going to use the same model for simplicity's sake, and add my latest stream, the connect carbon reports demo. Have to do the same as before. I have to switch it to a receiver, to a sender to a receiver. I select all because I am lazy. In this case, you could actually select partial parts of the model, and it will give you the carbon report of that specific part that you sent. But I am going to speed on to this one to allow us to get through all of the demos in time. And once that actually does its thing, if we reload now, you see, this is not going to work. Something happened. Pending. Oh, yes. Nice. So we actually connected it to Discord with yet another Discord webhook. So I actually got a notification that I have a carbon report ready in my carbon report demo stream, and I have a link to view it directly, so I can just go ahead. And now instead of actually telling me that what just happened here? I'm in the wrong OS. Let me just log in. There you go. So now instead of telling me that since we already created a commit in the main branch, it's already computed all of the data in the background for you. And once it's finished, it notifies you through Discord. So you can just go when it's actually done, because if it's a very big model, it may take a minute. So this is how it would look in the front end, which is these graphs. You will notice they are the same as the previous demo. Most of the front end is also the same. But we are kind of like receiving specific data from not only the original stream that we sent, but also our speckles, our new stream inside the carbon report. I don't have a new branch. That is not possible. I should have a new branch. There you go. So now we have a new carbon results branch that it was a commit that I made because I am the one that authenticated, and it's done through the Python application because our backend is a Python-based server. So if we go in here, there isn't really much data. There's just a result object with some steel, timber, and concrete results that have some carbon cost and some volume that we can then consume back into our application. So it's kind of like a simple, straightforward approach, but slightly more complex setup than the previous one. And all of the code for that one, if I manage to get to back to my slide, is, there you go. So all of the code for that one is available on GitHub in our Speckle account. You will also find there the deployed URL to actually use the app and the blog that explains how to use it. Do be aware that you will not get the Discord notifications. We will, because it's hooked directly to one of our specific channels. But I personally have it muted already, so feel free to hack away. And with that said, I'll give it back to Claire to do another super cool demo.
Yeah, so the next one is a very simple application that's just trying to integrate some Python machine learning resources. It's an application where you take an image, upload an image through our front end application built through Vue. We'll process the image in the back end with a pre-trained data set and generate a 3D point cloud and save that to a Speckle stream. So I will attempt a live demo as well of this one. So our front end is super simple. It's just built in Vue. You have the option of uploading an image. You can go to ml.speckle.dev if you want to test it out yourself. You can do this on mobile as well and snap a pic with your phone and upload an image. And in the background, we're processing this image with a sort of pre-trained model. It's a pre-trained machine learning model that was trained on the NYU depth data set for interior photos, so it works slightly better with photos of interiors. And the code was based off of a paper on high quality monocular depth estimation. And what's happening in the background is that the image is being fed into this model, and a depth map is being output, we're processing the depth map into a series of XYZ point coordinates, doing a little bit of post-processing on the resulting points, and then spitting that out, generating a speckled point cloud and spitting that out to a stream. So now that it's finished processing, we get a link to the stream that was just sent, and then you can take a look at that on the front end. This was a image that was uploaded. It is a very kind of janky 3D point cloud now. And the whole point of this exercise was to see how quickly we could take capture data in the real world and then send it directly to a stream to be retrieved back on any connectors that you would want. So for instance, I can take that link, open it up in Rhino. Adding the stream here. And we should be able to pull that point cloud straight into Rhino. This was one of the photos that was taken on our retreat very recently. So yep, very basic proof of concept for integrating some existing machine learning resources. And this was built over the course of a couple of hours. We had a one-day hackathon during our retreats. Both the Carbon app that Alan demoed and this application were built within that day. And
I say 6 hours, maybe something like that.
yeah. Let me move back to the presentation.
I mean, granted, we did code the part of the platform, though, so we quite fast at coding with it, but
yeah,
yeah, it's pretty straightforward once you get over the initial hurdles.
Yep, and oh, there was our video, and the tech stack for the ML app is as listed: Vue.js for the front end, pre-trained machine learning model, and we use Speckle's Python SDK for generating the point clouds and sending it to a stream. And yes, we have some links as well if you'd like to look into the code yourself or test out the deployed app at ml.speckle.dev. And finally, we have one more demo. It's also going to be a quick one. This was kind of a spontaneous experiment between Alan and I to essentially create a IFTTT Speckle connector. And if you guys aren't familiar, IFTTT is if this then that. It's a no code based platform for triggering certain events or chains of events based off of any platform or service that has created a service on if this and that. Let me try to do a live demo there as well. So if we go to IFTTT, we've built out, let me just archive this one and do it live. So if this then that has quite a few different platforms integrated already with it. What you can do is explore the Speckle service that we just deployed. You do that by creating your own, they call these applets on if this and that. And when you navigate to creating your own applet, you have the option of adding a first event, which is a trigger. And then that trigger can then trigger a few additional actions on top of that. So we have our Speckle service here. Currently, we just have an event for doing something whenever you create a commit to your Speckle stream that you put in. So when you select this option, it asks for a stream ID and the branch that you want to listen to. And we can just create a new stream on our front end. Let's just call this IFTTT. And then on this stream, we retrieve the ID from the URL and plug that into our IFTTT trigger. We're gonna just listen to the main branch. And once you create this trigger, you can add additional queries. We haven't fully fleshed out. It's just a shim app that we developed to integrate between our own API endpoints and the ones that IFTTT are expecting for any service that you add to their platform. What we can do is, for instance, then have this trigger every single time you send a commit to the stream that we just created, then, for instance, send yourself an email. And I can input, for instance, ingredients. So in the body, maybe I'll just type a very simple message that takes the username of the person that created that commit. Just send some stuff from. We can also retrieve our source application from that commit and also a date time as well. So now that you have your app set up on the background, what the service does is it listens for a webhook that is set up on that stream automatically. And when a commit is created on that stream, then it will then push that information, activate the trigger on IFTTT, and the corresponding action, send me an email, will fire. So we'll save that applet and let's go back to Rhino. Let's just create a very simple box and add that stream that we just made. We're gonna switch this stream card to sender and create a commit. And fingers crossed, this will fire the applet that we just made. So if we go back to see, it might take a bit for the applet to run. And there we go. Just received an email from IFTTT with the commit information that we just laid out in our applet. And yeah, that was completely no code. We can develop additional functionality for our IFTTT connector down the line if people are interested. And let me switch back and we can take a look at the stack. But yes, for the shim app, we used glitch.com. There's actually a Hello World demo, like sample service, IFTTT service template that we just used and like hacked together very quickly within a day, half a day, Alan, with some
A,
troubleshooting
a day
afterwards.
total after the headaches, mostly because documentation is one page and
Yeah.
everything. It's like very sparse, so we had to kind of like wing it by practice.
Yeah.
But yeah, it's basically an Express.js server with some REST endpoints. It's nothing fancy, really. It's just IFTTT wants the data some way. We send the data in a different way, and we created this server to bridge the gap between the both, so that Speckle would talk the IFTTT language and then give out like some meaningful variables that you could use down the line. No? This has limitless possibilities, but we also make no promises that this will become a thing. But you can definitely deploy your own and have like your own private kind of like applets and services. So it's something that for in-company processes may also be interesting, regardless of us doing a Speckle connector officially or not. If your company already uses IFTTT, it may be a very interesting choice, and it opens up many management possibilities. Like this was just one step, but you could also automate adding specific collaborators to your streams, adding specific data from Speckle directly into your management data software or your time tracking software, or whatever it is you want to connect to that IFTTT already supports, including turning all the lights in your house on when somebody sends a commit, which we should do as a joke, only, if only.
Cool. Well, that was it for all of the demos. We have some resources for getting started if you're interested. Our main website, our dev guide, and our community for troubleshooting / new ideas. And yeah, I think we'll just open up the floor for Q&A. Feedback. I feel like we've seen actually quite a few like really cool Speckle applications from presentations earlier, kind of put ours to shame, but it was just
Actually, real apps being used in real projects.
Yeah.
No, super cool. I already answered a couple of questions from Jeroen and David Morgan, but just to kind of like deepen a little bit on the topic, David Morgan asked us if you could add buttons to a front-end server, which yes, you can if you deploy your own Speckle server, which is also a totally doable thing. So yeah, it's totally, you'd totally be open to hack away on your Speckle server if you have some apps that you've already developed to kind of like bridge the gap between the both of them and make your users access the third-party apps in a smoother way. But I don't think we will do that in our XYZ unless we actually develop some like long-term applications that stay in the ecosystem forever. No. Then we also had Jeroen when automatically creating a stream for a whole. It is possible to update the Speckle stream once somebody has pushed something to Beam 360, because it's basically webhooks. Again, everything works webhooks nowadays to run notifications. So you could have the same way we've done the IFTTT service that bridges the gap between Speckle, the Speckle language, and the IFTTT language, let's say. You could have a Speckle service that basically receives the notification from Forge, does some kind of like data automation processing, and pushes some information out to Speckle. We've not done that demo yet, but I am wanting to do so. So hopefully, hopefully we will have some time soon to do another hackathon. And then we have AJ.
Yeah, we can also, there's a question in chat about authentication. So you can actually set your app tokens right through our front ends on your streams, and through your account on if you're using, for instance, our public server. We can generate personal access tokens and also application, like register and manage like third-party applications through our front end.
Yeah, Dimitri just pasted the link to our explanation on the dev docs. But if you're unsatisfied, feel free to reach out to us and we'll be happy to discuss more. Are there any connectors for Azure currently available? But feel free to let us know in our community exactly what would you be looking for, because we're always open to expand the ecosystem as much as our workforce allows us and our time allows us to do so, which is currently stretching thin. So I make no promises on that. But if there's enough community support, we would definitely look into not only Azure, but any other different platform that our users are interested in getting connected to Speckle. No, if it makes sense, we'll be happy to look into it and at least do some kind of proof of concept mock-up app to at least demonstrate that it's doable and how you could do it. This will be happy to.
Cool. If that's everything, all of our apps that we just demoed, the repos are available on GitHub. If you like what you saw, then give our repos a star. It does help.
Please star us. Cool. Well, thank you very much for coming. It's been a pleasure.
Awesome. Thanks, everyone, and happy hacking.